Today we will solve an example from NCERT Chemistry Textbook Part 1, Chapter 3, that is electrochemistry. The conductivity of 0.001028 mole per liter acetic acid is 4.95 into 10 raised to minus 5 Siemens per centimeter. Calculate its dissociation constant if lambda m0, that is molar conductivity at 0 concentration for acetic acid, is 390.5 Siemens centimeter square per mole. The formula to calculate dissociation constant K is K equal to C alpha square upon 1 minus alpha, where alpha is the degree of dissociation. That is, concentration of solution is 0.001028 mole per liter. The formula to calculate alpha is alpha equal to lambda m upon lambda m0. Now lambda m is molar conductivity of acetic acid, which we again need to find. The formula to calculate lambda m is lambda m equal to kappa upon C. Kappa is the conductivity of the solution and the value for it is already given in the numerical, and we also have the value for concentration, that is C. We substitute the value of kappa and C in the equation. Then we'll convert liters per mole into centimeter. We know that 1 liter is equal to 1000 centimeter cube. So in place of per liter, we write per 1000 centimeter cube. After simplifying this step, we get 4.95 into 10 raised to minus 2 upon 0.001028 Siemens centimeter square per mole. The steps for simplification are shown here. We will further solve it using log. Therefore, we write log lambda m is equal to log of 4.95. Here it is into, so we write plus log of 10 raised to minus 2. This is division here, so we write minus log of 0.001028. Next, we make sure that all are in simple log form. So this is already in simple log form, and then we write this. Here we have to shift the decimal 1, 2, 3, 2. That means 3 places to the right. Therefore, it becomes 10 raised to minus 3, and here it becomes 1.028. Log of 10 raised to minus 2 is minus 2. Similarly, log of 10 raised to minus 3 is minus 3. Using log table, we get the value of log of 4.95 as 0.6946 and log of 1.028 as 0.0119. The steps to calculate log values are shown here. After solving all these steps, the calculations are shown here in the boxes. We get log of lambda m is equal to 1.6827. To calculate lambda m, we have to find the anti-log of 1.6827. Here the characteristic is 1, therefore in the answer we write into 10 raised to 1. And using the anti-log table, we'll find the value for 0.6827. So we see 0.68 under 2, that is 4808, and in the mean difference 7. The value is 8. After adding, we get 4816. So we write here, and after the first digit we place a decimal in the answer. Or we can also write it as 48.16 Siemens centimeter square per mole. Using the value of lambda m, we will calculate alpha, that is degree of dissociation. It is alpha is equal to lambda m upon lambda m0. Now we have the value of lambda m, and lambda m0 is already given in the numerical. Using log, we write log alpha is equal to log of 48.16. Now here it is division, so minus log 390.5. Next, we need to convert them into simple logs. So here we have to shift the decimal to the left. Now here we are shifting one digit, so we are writing into 10 raised to 1 since it is left. Now here we have to shift the decimal 2 places to the left, so we write into 10 raised to 2. Log of 10 raised to 1 is 1, log of 10 raised to 2 is 2. The value using log table for log of 4.816 is 0.6826. Similarly, using the log table, when we find this one, we get the value as 0.5916. The steps to calculate log of 4.816 and log of 3.905 both are shown here. Even how to calculate the characteristic is also shown. After solving all the steps, we get log alpha is equal to minus 0.9090. Then to find alpha, we find the anti-log of this given negative number. Now since this is a negative number, we need to make the mantissa positive, and for that we know that we have to add minus 1 to the characteristic and plus 1 to the mantissa. The calculations are shown here, and finally we get minus 1.0910. In the anti-log table, we see 0.09 under 1, and the value is 1233, which we have written here. And the mean difference, here it is 0. We have to see it under 0, and there is no 0 here. So we take the value as 0 only. After the first digit, we place the decimal in the answer. So we get the value of alpha as 1.233 into 10 raised to minus 1, or we can also write it as alpha is equal to 0.1233. Now we substitute the value of alpha in the equation to get the dissociation constant K, and after substitution we get the value as 0.8767 in the denominator's place after subtraction. We will solve it using log. So we write log of K is equal to log of 0.001028. Here it is into, so we write plus. Then here it is 0.1233 square. So we write it as 2 log of 0.1233. And here there is division, so it becomes minus log of 0.8767. Next is to convert them into simple logs. So in this case, we have to shift 3 decimals to the right. It becomes into 10 raised to minus 3. Here only 1 decimal, so it is 10 raised to minus 1. And in this case also it is only 1 decimal we are shifting, so we write again 10 raised to minus 1. Log of 10 raised to minus 3 is minus 3. Log of 10 raised to minus 1 is minus 1. Same here also. The steps to calculate log of 1.028, log of 1.233 and log of 8.767 using the log table, the steps are given over here. After solving all these steps, we get log of k is equal to minus 4.7491. The steps of calculations are also shown here in the boxes for the respective steps. To find k, we have to write it as anti-log of this negative number. For this, first we need to convert this negative mantissa into positive, and for that we know that we have to add minus 1 to the characteristic and plus 1 to the mantissa. The calculations are shown here, and finally we get it as minus 5.2509. Here the characteristic is minus 5, so we know that in the answer we have to write it as into 10 raised to minus 5, and in the anti-log table we have to see 0.25 under 0, mean difference 9. 0.25 under 0 is 1778. Here we have written, and mean difference is 4. So we add plus 4 and we get it as 1782. And while writing the answer, we know that after one digit we have to place the decimal. So we get the value of k, that is dissociation constant, is equal to 1.782 into 10 raised to minus 5 mole per liter.